Next, we are going to discuss ANOVA. For ANOVA, so we are going to discuss ANOVA. For ANOVA, at first, you need to prepare an ANOVA table. Okay, so about ANOVA, ANOVA is a kind of test or hypothesis testing wherein it is used when we have three or more samples or three or more populations to test, and if we are asked to test the equality of these three or more populations, then we will have to go for ANOVA. That is, before we studied t test and z test, and in t test and z test the problem is that we can test or compare between two group of data only. Now, if we have more than two group of data, then we will have to go for a test called ANOVA, which is among the F family. So, in order to do ANOVA, first step is to prepare an ANOVA table, and an ANOVA table looks like this. Now, I'll briefly explain each and every terms in this. So, step by step. Now, at first, in order to do ANOVA, we'll have to find T. T means sum of all observations in the row and columns. So, I already have a question here, and with this question, I can explain to you. Okay, so here, see, um, here below are given the yield per acre of 5 trial plots of 4 varieties of treatment, and you are sorry, you are asked to test if all these treatments are equal. Okay, something like this will be your question. So here you have 4 treatments, and you are asked to test if there is any significant changes that is happening due to these treatments. Okay, so for that, so here if you can see, you have 4 group of data for which you have to check the difference. So here we cannot go for t-test, instead we'll have to go for ANOVA. Now, to prepare ANOVA table, the first step is to find out T. Now, what is T? T means the total of each and every values in this group. So here we have from starting from 42 to 66. We have a lot of data, and for this data, we'll have to calculate the total. So I have already prepared this thing here. So let us calculate T here. T is equal to first step plus the next one plus next sorry next one plus next one plus next one plus next one. Okay, so I got the total of all these values, that is 1300. Now let me also take the total of all these uh, treatments. This is 240, then next one is 330, then 330, and then we have 400. Okay, so this is the your column totals, right? So we have our column totals also here. Let me arrange it once again. Okay, yeah. So at first we took t, which is the total of all these values given here. And this is the total. I'll write this here so that you don't get confused. So t is the total of all these values. Sorry. Then next, what we need is, okay. So what we need is SST, that is sum of square of all observations minus t square minus divided by n. This is SST, sum of square of all observations minus t square by n. So at first we already found out t, now let's also find out t square by n. Okay. So t of t square, let me put it as t2. Okay. T square by n, right? So 1300 is our t, is equal to 1300 into 1300, this value divided by n. N means the total of all the numbers. How many numbers do we have? So we have 5 rows and 4 columns. So total we have 20 numbers, right? So 20 is our n. Okay. So we got 84,500 as t square by n. Okay. Now we need what? SSC. Now for SSC, it means the total of each group. That is, here we have sigma x1, this is sigma x2, sigma x3, sigma x4. So SSC is equal to sigma x1 square by n plus sigma x2 square by n plus sigma x3 square by n plus sigma x4 square by n minus t square by n. This is our formula, right? So I'll show you the formula once again. SSC is equal to sigma x1 square by n1 plus x. Okay, this is our formula. So let us substitute the values again. So our this one x1 square, x1 square, I'll calculate the square values over here. This is equal to this. Okay, so this is our sigma x1 square, x2 square, x3. I'll put it as total square. Okay. So sigma x1 square, x2 square, x3 square, and x4 square. Okay. So I just wrote it here in order to ease my calculation. So here this is equal to sigma x1 square divided by n1. n1 means the total number of items in the first group. So it is 5. Here we have everything equal, but it need not be equal always. Okay. So that's why this plus x2 square divided by n2 plus x3 square divided by n1. 3 plus x4 square divided by n. Okay. So we got it as 87080, right? And this is not, sorry, this is not NT. We have to do one more thing, that is minus t square by n. This is also a step. Okay, so 2580. This is our SSC. Now, yeah. So we got our SSC. Now next we need SST. SST, that is totals. SST means nothing but the square of each value in this. All the values squared, add it all up. Okay, sum it up, and then um, minus t square by n. That is this one. Okay, that is what. So I think I'll prepare one more table wherein I'll square it. Okay. So when you're doing this thing, you need not do like this, but it's for my ease. Yeah. So this is equal to into, okay. So same way we can delete. Okay. So I have taken square of each values. Now I think I can add it all up. Okay. Right. I'll add this up. Or I'll add each of it. It's equal to 1 plus, sorry, plus, 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 now this is not all. This we need to do minus t square by n. For all the values, you will have to deduct t square by n at the end. Okay. So we also got SST. Now what we need in our table is we have SSC here, SST here. Now we need SSE. So it is simple. It is SSE. This is equal to nothing but SST minus SSC. Okay. So now we'll put all these values back. Control C, SSC. Oops. think I'll delete all this. SSC is 2580. Then next one SSE, which we already found out at 1656. Then SST, it is 4236, right? Yeah. Now K minus 1. Now N and K. Now K stands for the number of groups that we have. Okay. K stands for the number of groups that we have. Okay. So it is 4. So it is 4 minus 1. 4 minus 1, it is 3, right? So I'll write it as equal to 4 minus 1. It is 3. And your N minus K. Now N stands for the total number of items in this group. So here your N is 20, right? All these groups together, you will have 20 items. So your N is 20 minus your K is 4, right? So I'll put equal to sign before that. So we'll get the value. Okay, 16. Now again N minus 1 does this column, but does the total of these two. So N minus 1 is 19. 20 minus 1, or if you add both these columns together, you will get 19. Now this is it. Now we have MSC and MSE. Now MSC is nothing but it is SSC divided by K minus 1. Okay, just go through the columns. That's it. And your MSE is nothing but SSE divided by N minus K. Okay. Now you got two values here, that is MSC. Okay. So I'll write it as MSC is equal to, oh sorry, then your formula will not work out, right? So it is 860 that we got. MSC is equal to 860 and 103.5, right? So MSE is equal to 103.5. Yeah, this is the value that you got here. Now, in order to calculate your F ratio, F, it is equal to nothing but your MSC, that is 860, divided by your MSE, that is 103.5. So you get 8.309. This is your F value. Now let's go back to your slide wherein we have written all these things. Okay, so you got your MSC divided by MSE, that is 8.309. Okay, now what you need to do is you need to find the degree of freedom. Degree of freedom, again, if you look into the table, you will get it. That is, it is K minus 1, comma N minus K. That is again written in our table. That is 3 and 16. So that is our degree of freedom, 3 and 16. So at 3 and 16, 5% level of significance, your degree of freedom value will come around 3.24. If you check your book, you will get the value. But don't worry, for certain values, it will not be there in your logbook. for such values, it will be given directly in your question. So just identify the correct degree of freedom and then pick out the correct value for your table value. That's all. Then, so you have your um, table value here, and you can see that your table value is much lower than your test statistic, and therefore you reject the null hypothesis, and therefore your conclusion will be there is significant difference between the treatments. So hope this is clear to you. Now let us go through it once again. That is, for finding out ANOVA, first you need to prepare an ANOVA table which looks like this. So you need to by heart this table at the first place. Now for your ANOVA table, the first step that you need to do is find out your t value, which is the total of all the values in the question. So it is your t. Then next step, t square by n. That is, we already have found out your t. Then square it and divide it by n. That is, n means the total number of items. That is, in this particular case, it is 20. So t square by n you found out. Then you found out the SSC. SSC means you're calculating yeah, column totals. So yeah, for your SSC, you will be calculating your column totals, that is 240 square. 240 square by n1 plus 330 square by n2 plus 330 square by n3 and so on. So for how many groups you have, that must you have to calculate. That is your SSC. Then you have to calculate the SST, that is the square of each and every values, the total of all the square of each and every values divided by square of each and every values minus t square by n. Okay. And also for SSC also you need to deduct t square minus n by n, and for SST also you need to deduct t square by n. Then your SSE, which is the difference between SSC and SST. SST minus SSC is equal to SSE. Then fill all these values into your table. Then you have k minus 1 and n minus k. K means the number of treatments or the number of groups that you're having. In this particular case, you had 4 groups, and therefore k minus 1 is 3. And n means the total number of items in the group. It is not the total of items, it is the total number of items. So in this, we had 20 items, and therefore your n was 20 minus k was 4. And therefore 20 minus 4, you got 16. Again, you add it up, that is 19, or n minus 1. It is 19. Then after finding this much, then you can simply divide your SSC divided by k minus 1 is your MSC, and SSE divided by your n minus k is your MSE. Then if you divide between MSC divided by MSE, you will get your F value. Then go for the degree of freedom, that is n minus 1, sorry, k minus 1 comma n minus k. At that degree of freedom, find out your table value. Then compare between the values. If it is lower, if your test statistic is lower, you can accept the null hypothesis. And if your test statistic is higher than your table value, then reject your null hypothesis. Okay, so that's all. Thank you.